Okay, so I think I'm live. Yep, I'm live. So, hi everyone, welcome to another interview series. So, yeah, like we'll be starting with today's questions. As you see, there are three questions, and you must have tried them. So, yeah, like before we start, you can let me know how was the contest overall. Did you like the questions? Were they easy, or did you find any difficulty with the questions? For me, I felt the problem set was pretty easy. But yeah, like let me know what do you feel about the problem set. Context criticism. Okay. First question, Java. We can try writing in Java, although I'm not. I haven't done a lot of CP in Java, but yeah, like we can try to write the first question in Java maybe. That if that works. We'll take a look on this. All right. Anything else? You have to go with Java. We have the thing was cool. Uh, Last question was difficult. Cool. We'll see how we can solve that. Okay, so let's quickly start with the first question. Again, like the first two questions, I also know they're pretty simple. You must have, like, everyone must have solved that. And I'm expecting that everyone has solved that until and unless there are some issues with Java or something like that, right? You should have solved both of them. So first question is, you are booking a taxi. There are infinite number of points on the x-axis and the current position is curved. There are n taxis near you and the position of those taxis is given in an array pos, where pos of I denotes the position of the ith taxi. You are also given an array time where time of I denotes the time taken by the ith taxi to cover 1 unit distance. Your task is to find the minimum time to board a taxi, right? Okay, are you not able to hear me? Let me know in the chat once. Are you not able to hear me, or is it okay now? The voice is not coming correctly. Let me know if it is not coming correctly. I can fix. Okay, let me just fix it. I'll just change the source for this. Okay. Is it better now? Is it better now? Let me know if it is better now. Which one is better? Like previous one or next one? This one. Let me know. I'll switch to that microphone accordingly. Cool. All right. So yeah, like we are given the time and the position where the taxis are and also our current position. We have to find what is the minimum time to board a taxi. The problem, so what it basically tells is that we are at a point, right? We are at a point on the x-axis and there are some taxis at any point of time. There are some taxis at different positions on the x axis and they're traveling by some speed, and assume that all of them are moving towards you, right? All of them are moving towards you. So what is the minimum amount of time that is needed for you to board a taxi? That is, what is the minimum of amount of time needed for a taxi to reach you? So what is the amount of time needed by a taxi to reach you? The distance, the difference of the distance, and what is the speed, and also you covered 1 unit of distance in this time. So the amount of time you are covering x units of distance, so it will be time of I into x, where x is the difference of the absolute difference of the positions, that is pos I minus curve, right? So for the ith taxi, simple thing, not drawing anything or something. For ith taxi, we what we want to see, what is the value of time of I into abs of current, or yeah, current minus pos of I, right? So this should be the equation, right? This should be the equation. So So let's start with the question. So let's try to write the code for this. So initially we'll take long or it should be integer, right? So int answer. Initially let's take it to be the first element. So math.abs math.abs current minus position of I, current minus position of I, position of 0 into time of 0. Let's start with this value, right? And for int I equals to 1, I less than n, I plus plus, answer equals to math dot min answer, and math dot min answer, and it should be what, time of I. Also it should be into time of 0. Okay, time of I into position of I minus current, the abs of that, math.abs of this value, position of I minus current into time of I, and finally we can return answer. So that should be the code. Let's run this. It is giving 2, which should be correct. So let's submit. So this is working, the code is working. Anyone like someone faced problem with Java? I believe now the doubt is clear, like it's working with Java as well. Cool. So yeah, there was nothing in this problem. Let's go to the second problem. The second problem is also very simple, like there are multiple solutions, and even if you do a brute force it will work. So again, like not a lot to explain. Whatever the question says we have to do that, right? So you are given the head of a linked list. You have to replace all the values of the nodes with nearest prime number. If more than one prime number exists at an equal distance, choose the smallest one. So what we have to do is, we are given a linked list, we have to round each number to the nearest prime number, that is the one less than it or the one greater than it, and if it is at equidistance from both of them, you will choose the smallest one, that is the lower one, right? So 2, 6, 10, it will become 2, 5, 11. See, the nearest prime number to 6 will be, so for 6 there are two prime numbers nearby, 5 and 7. So the nearest one will be both are at equal distance, so we'll choose the smaller one, which is 5. So 2, 5, 11 will be the answer for this, right? So what we have to do is, we have to round out each of the numbers to the nearest prime number. The constraints that are given is, number of nodes is 10 to the power 4 and the value of each node is 10 to the power 3, right? Value of each node is 10 to the power. So we have to do this, right? By brute force, I mean, what we can do, like very simple solution, we have to move each of the number to the nearest prime number. Now the only thing that we need to do is, given a number, we have to check if it's prime. The brute force way to do this, which will work actually, is, given a number, if the number is a prime number, you have to check that. We have a square root of n approach to check that, like we'll go up to square root of n and we'll check if n is divisible by I. So in that case it is not a prime number, otherwise it is a prime number. Like one of the factor has to be less than square root of n, using that logic. So we can, for each number we can iterate, we can go to the nearest square root of n number, and we can check what is what we can easily find, like that, what is the nearest prime number, right? So, and also another property that will be valid here is, the distance between two prime numbers, the distance between a number and its nearest prime number, like greater than it or less than it, is very small, and also the numbers are within the range of 1000. So definitely it won't be a lot, even if it's order of n, which definitely it is not. It should be good, right? So this actually is something that we can use to calculate the find the near, like for every element we'll go one step at a time upwards, one step at a time downwards, and see if that number is a prime number or not. If it is, we'll break there, and then we'll compare, like the one that is greater than, one that is less than. We'll compare the distance between them with the current element, and then we will assign, like, we'll move accordingly, right? So that's a brute force way. However, we'll not use a brute force way. We'll try to do it a bit better, right? So what we'll use is, we'll use the sieve of Eratosthenes method. So let's compute the prime numbers, right? So we want to maintain the prime numbers in a set, so let's call it set of primes, and void compute primes, right? So we'll compute the primes up to 100, 1000. So 1000, let's say up to 1001 we are computing all the prime numbers, or 1000 up to 1000 we are computing all the prime numbers. So for, in fact, let's compute up to, like, let's say 2000, because the nearby, so 2000, yep. For so vector bool is prime n and false. Initially everything is initially everything is prime, set to true, is prime. So for int I equals to 2, I less than I into I, or I less than n, that's also fine, I less than n I plus plus. For int j equals to 2 into j equals to I into I, j less than n, j plus equals to I. So we are just writing the code for sieve, right? So for sieve, what we'll do, if is prime I, if is prime I, then we'll then run the loop only when is prime of I. So if is prime I, in that case for int j equals to I into I, j less than n, j plus equals to I, is prime j equals to false. So we are going to the multiples and we are marking them as not primes. And finally for int I equals to 2, I less than n, I plus plus, primes dot insert I. And when do we insert? When it is a prime, right? So if is prime of I, then we'll insert primes dot insert I. Okay, now we have inserted all the prime numbers. Means sieve is TLE. Okay, let's see if it is giving TLE to us. So let's compute the primes first. So compute primes. We have computed the primes. Also make sure to clear the prime set. So primes dot clear compute primes, and then what we'll do is we'll go through all the elements one by one. So node start temp equals to head, and finally we'll return the head definitely. Okay, node start temp equals to head, and while temp not equals to null, and we'll do a temp equals to temp of next here, temp equals to temp of next. So int value is temp of data. So we want to find the nearest element in the set that is greater than val, first of all. So auto it equals to primes dot lower bound. So we want to find the primes dot lower bound on val. That is, what will it return? It will return the first element in the set that is greater than equal to val, right? So if value at it, if value at it is not equals to val, then only will process. So int upper is value at it. If it not equals to primes dot begin, it minus minus and val int lower equals to value at it, and before that we'll do it minus minus lower, and we'll come here we'll compare else else temp of data. Here temp of data will be val, temp of data will be upper, here if if what if the condition will be what, the condition will be if data, that is val, if minus if upper minus val is less than lower val minus lower, in that case temp of data should be equals to upper. In only in that case it should be equals to upper, else it should always be lower, right? So temp of data equals to lower. If it is equal or less, in that case it should be the lower. So temp of data is lower, and otherwise this, and temp equals to temp dot next. So this should actually work. Let's try to run this. uh, Class node has no membered name data. Okay, what was the definition? The definition was val. Okay, so it's not data, rather it's val. So it should be val here, and temp of val, it should be set to temp of val here, temp of val here as well, and temp of val here as well. So let's run this now. Okay, 2757 2869 2869 should be 2757, I believe. Let's check this quickly. 2757, that's true. We'll take one more example, 11520. Let's take the example of 11520. 11520, and my output, let's see my output. So 21319, is it 21319? 21319. So let's submit this. Okay. Okay, it is indeed giving a TLE. It should have worked, but like this is much faster. But again, like I believe, okay, let's without sieve, then let's go for the brute force way only. So what we'll do, this is giving TLE, but again, like this shouldn't have given TLE, because again, like order of everything is order of log n here, so it's much better. But yeah, like okay, one thing, if a number is repeated, we might actually want to store that as well. But that's fine. Okay, let's do one more thing, like pool. Let's create a helper method is prime. Compute primes. We're computing this, we're doing the sieve here. Temp is not equals to null. Temp of val primes dot lower bound val. Uh, okay, upper. And if we memorize these values, that also will might help. Do you have an array where we use have the array why we use set? Yes, set, because we want to search quickly, right? We want to search the nearest number that is greater than the element, right? How would you search quickly a nearest number greater than the element? So you can use a array as well instead of a set. I think using an array would be better, because yeah, like I think in using an array would be better, because we can use lower bound there as well, and it is not we don't have to update elements. So maybe let's just update it to an array, right? So let's just update it to a vector. So vectors primes dot pushback I. Let's just do this. Primes dot pushback I is prime, and here instead of like this, what we can do is lower bound primes dot begin primes dot end, and the value that we want. So we are doing this, and that should also work. Let's run this. So instead of so is prime expecting something, vector int primes, vector bool is prime of I, primes dot pushback I. 39, line number 39, bool is prime. Okay, This is not needed. Yes, inserting takes login, but again, like uh, yes, set was not the best choice, I understand, but yeah, like we can use an array as well, because set is better when you have dynamic insertions, dynamic deletions. In this case, once we are generating the array, we are not changing this primes array, so that should be fine. Let's test it out with the array. If it doesn't work, then we have to think about some other optimizations or something else, but let's try it out once. Okay, it's still not working. So actually, I think, why is it not working? Uh, we can have the is prime array. We can maintain this is prime array. We can quickly check. Maybe because log n is not better than, like, the distance between two primes is much lesser than that of log n. So we are unnecessarily doing a binary search. So what we can do here is we can also do one more thing, that hey, let's make this a vector of bool. Let's store the is prime here only. Is prime, and initially it's of length 2000 and everything is false initially, right? 2000 and everything is true initially. So yes, is prime, everything is true initially, and is prime of j is false. So here this marks whether a number is prime or not. This will mark if a number is prime or not. So up to 2000 we are uh, generating all the prime numbers. Now here what we are doing is primes, is prime, compute primes. Right, so compute primes, first thing that we do is prime equals to vector bool 2000 false. Vector bool 2000 false, sorry, true should be the first thing that we should do, right? And now what we are doing instead of this logic, so here what we were doing, here we were finding the nearest prime number by doing a binary search on the primes array, but instead of that, let's do something else. So int num upper equals to temp of val, int lower equals to temp of val. So first thing is, if temp of val is a prime number, so if is prime temp of val, right? If it is a prime number itself, in that case will do nothing. So only in the case when it is not a prime, we'll do something, right? Now first thing that we'll do is, what we'll check is upper and lower is there. So if okay, if it is 0 or 1, if temp of val equals to 0, or temp of val equals to 1, or temp of val is less than equal to 2. If temp of val is less than equal to 2, in that case temp of val will be 2, right? So let's discard the case where lower doesn't exist. Temp of val is equals to 2. Now while lower minus minus, if is prime of lower, break. Similarly, while upper plus plus, if is prime of upper, break, right? So we have found the nearest prime numbers both on the ends. And now if val, temp of val, so if temp of val, sorry, upper minus temp of val is less than temp of val minus lower, in that case temp of val is equals to upper, else temp of val equals to lower. temp of val equals to lower. Is add one, subtract one, check it is prime or not. Yep, that's what we are trying to do here. I believe the difference between definitely it's much lesser than that of log n, so this might actually work. So let's try to run this first. We are going like one step on the front and the back. So identifier 22 vector bool is prime. Vector bool is prime and is prime of I should. Okay, 2757. Let's run this. Uh, we are getting something wrong here. Is prime 210 for 1. For 1, what we are doing? Why is we are doing this? Okay, is prime, we have to set these also to false. Is prime 0 is equals to is prime 1 is equals to false. I have to set this as well. Sorry, my bad. I'll tell you, just give me a second. Let me just run this quickly and then I'll tell you like which one is better. Right. 13, that should be fine. Okay. So and if this time limits, then I'm not sure, but I will try to do some memorization here, that if a value is repeated, this is also time limiting. Try handling for case 1. Yeah, that's done. For 100 we are doing log 100, but here we are slightly optimizing it for average space. Call the first to generate prime, then use primes that generated. Call the first only to generated. Call first only to generate the primes and then use primes on the generated. Don't call compute prime every time. Yeah, I think compute prime every time doesn't make sense. Like it can be done only once, but uh, yeah, like hmm, what we can do about this? Maybe in the constructor we can specify, right? So in the public section, let's create a constructor and then we can compute call there only. Whenever the object is created, it should do the compute prime, right? So this part should be done in the constructor. Okay, that should be done. And also let's maintain a map of nearest prime. So uh, maybe a hash map or something like that. Unordered map int nearest prime for memorization. And here what we can do is uh, yep. So here uh, is prime temp of val. So for the primes it doesn't do anything, but here temp of val is equals to 2 nearest prime temp of val equals to 2. uh, okay, before we do that, let's submit once again. Like again, like this will add another complexity of storing the values, but before that let's submit once and see if this is actually passing. uh, Otherwise we have to do something else. We have to memorize or something. Still it is going for time limit. Upper plus plus is prime upper. For what is the nearest prime number? Prime number greater than 1000. What is the prime number greater than 1000? So after 1000 it should be 1009 should be a prime number, right? So it should not go beyond that. Okay. So it should be 1009 maximum. We are computing up to 2000. Maybe we can restrict this to 1110. We can restrict this to 1010 and then compute is prime int n I less than n is prime I, and 1010 should be true. Okay, should be true. Compute primes. Okay, let's go for let's submit this, and meanwhile we'll go with the nearest prime approach as well. So here we'll store this doesn't do any computation, and here we'll store nearest prime of temp of val is equals to upper, and nearest prime of temp of val is equals to lower in this case. And also here, first thing that we'll check is if nearest prime of temp of val not equals to 0, in that case what we can do is we can directly assign the value. Temp of val equals to nearest prime of temp of val, and the entire logic goes under else. So this remaining part will go under else. Let me know if you guys have done in a better way. Is prime temp of val else temp of val less than 2. So let's run this. This should have worked. Uh, yeah, this should have worked. I'm not sure why this didn't work, but yeah, like this should have worked. Like sieve should have worked in the first place, but it didn't. So this should at least work. And again, like hash map should not have been needed, but not sure how the constraints have been set. Again, hash map for storing the queries of each node. Some might repeat. Still, its time limit exceeded. That's interesting. Solution. I don't have the solution. Not sure how to solve this. Can I see the submissions? Okay, only my submissions, and I cannot see all submissions. Not sure what is expected here, but it should have worked. Anyone has go with static global? You are asking me to make this static is prime. What will be the advantage of that? Yeah, we can make it like global as well. Is this part taking the time? Pre-compute entire solution for 1 2000. Maybe that might actually work, right? So pre-compute let's find the nearest prime number for each of the values. That might actually work. So as there are 10 to the power 4 nodes, then definitely it's much better to pre-compute the values beforehand. So maybe let's do something like this that will compute the nearest prime number for each of the elements, right? So uh, vector int, let's, instead of nearest prime, let's do it a bit differently. So this part let's completely remove. That's a good idea, actually. That's a very good idea. So what we'll do here, 1010, let it be up to this part. So is prime is done. Let's remove this part, and vector int nearest prime, nearest prime, or nearest prime, yes, nearest prime should be that. And solution vector int nearest prime should be a vector int 1010, and initially it should be initially 0, everything should be 0. Compute primes. Okay, is prime 0 1 is false. Now nearest prime, so nearest prime 0 is equals to nearest prime 1 equals to 2 for int I. So we'll run a forward pass and we'll run a backward pass, and we can see like which one is better. So for int I equals to 2, I less than n, so int last prime, for int I equals to 2, I less than n, I plus plus, if is prime of I, then nearest prime of I is equals to I, and last prime equals to I, else nearest prime of I is equals to last prime. So we can do a forward pass like this. Now the same thing will have to repeat in the backward direction. So yes, so last prime again, so last prime equals to 1009 for, and int I equals to, okay, so last prime will be storing the last prime value. So for int I equals to, again we'll start from the same way, n minus 1 I greater than equal to 0, I minus minus, right? I also the element should be positive. I'm assuming greater than equal to 1. So I greater than equal to 0, I minus minus, if is prime of I, last prime equals to I, else if last prime minus I is less than I minus nearest prime of I, the existing value, then nearest prime of I is equals to last prime. So we are storing this last prime like this. So that should store all the values. So temp and temp of val should be equals to the nearest prime of temp of val, nearest prime of temp of val, and temp equals to temp of next, temp equals to temp of next, and that should be it. So let's run this. Last prime of I, last prime equals to I. It's understandable, but again, like this was a good optimization that we have done. might not work again. But yeah, like pre-computing everything beforehand, because there are 10 to the power 4 nodes, and you have to compute for 10 to the power 3 values, but still it is not working apparently. So I'm not sure how to solve actually. But again, like the solution, again, it's very easy, although I'm not sure what the question demands or how the time limit has been set, or is it actually running temp. I think this might be going into some infinite loop. Let's just return head from here, and I want to see if that actually time limit that exceeds. Oh, that will not run all the test cases. So we cannot do anything. Yeah, we just have to next time we check for whether the prime. Yeah, kind of, yes. So basically here we are actually starting with initializing the nearest prime to be the prime on the left hand side, right? But after that, for in the first loop, in the second loop we are starting from the right hand side, and we are comparing if it is better than the if its distance is lesser than the nearest prime on the left hand side that is already there in nearest prime of I. In that case, nearest prime of I is equals to last prime. So that's what we are doing here. So yeah, that's the logic. Anyways, let's keep this question. I'm not sure how to get this correct. Let's go to the better question, which is this one. So you're given a string str. Click hint button once. Okay, the hint button. Which one? Oh, this one. So what they are doing is prime n equals to 2, while temp num1 num2 num1 num2 num, if num1 equals to temp of val equals to num1. Okay, while not is prime num1. Okay, it is doing a much worse way, I believe. It's doing the square root of n approach. It is not doing the sieve, and square root of n is apparently better than sieve. That's interesting. One second. Why is square root of n better than sieve? Doesn't make sense. It's prime of num2 num2 plus plus, and yeah, it is just finding the nearest primes, right? And it is doing in a brute force way. Then how is sieve not better? So let's go ahead with this optimization, another one. But yeah, like this will also not work. So expected this will not work. Anyways, apparently it's working for that code, but not this one. So yeah, just instead of doing sieve, you can go for a square root of n approach and check if that actually works. Otherwise, not sure how their code is working. I don't think I missed any case. Temp one, temp next, return head. So we are doing this only. Copy paste, run this. Okay, check this as well. Should work. This should work, because why not? But yeah, like let's see. Otherwise, that no, this should work actually. Oh, that was a plus code. All right, sorry, I don't know why I've written. But yeah, probably this will work. Apparently, oh, this is working. Nice. N equals to 3 return true. Not sure why it is. Anyway, square root of n is better than sieve. That's fine. Cool. Let's go to the last question. You are given a string str of length. Uh, you are given a string str of length n. This is a good question. Consisting of start opening brackets, closing bracket, and question mark. You have to replace each question mark character with either a starting or ending bracket character. A valid string is a string in which every opening brace has its corresponding closing brace and vice versa. So basically, we are talking about valid parenthesis strings here. Like it is a matching parenthesis string. A number of opening braces is equals to every opening brace has a corresponding closing brace. So these are valid, these are not. You are also given another integer k. You have to find the total number of unique valid strings you can generate. So you have to find unique valid strings that you can generate such that the maximum length of the substring of the string containing same character is no more than k. So no more than k characters can be same characters, and like no more than k consecutive characters should be a opening bracket, or no more than k consecutive characters should be a closing bracket. Since the answer can be very large, output it modulo 10 to the power 9 plus 7, and we can get a substring from a string by deleting several so basically what it tells is you are given a string with contents starting bracket, ending bracket, like opening bracket, closing bracket, and question marks. You have to fill the question marks definitely. So you have to find how many ways or how many strings, unique valid strings that you can generate. Valid means it should be a valid parenthesis such that no consecutive k character should be of the same type, that is should be a opening bracket or a closing bracket, and you have to find the answer modulo 10 to the power 9 plus 7. Okay, you have to find the answer modulo 10 to the power 9 plus 7. So let's understand this. Cool. So okay, so we have to count the number of ways, right? So whenever we come into questions, like you have to count the number of ways where you have choices, right? So if you think about it, in a question mark you actually have two choices, right? You have a choice of giving it a opening bracket or giving it a closing bracket. So whenever it comes to questions like you have two choices, you have multiple choices, and you have to count something, generally it's a dp question, right? Generally it's a dp question. So let's actually go ahead and try to formulate the recursion. So fn so what are the states that we need? First is n. N means we are left with the first n characters. We are left processing the first n characters. How many ways can we process the first n characters such that no more, how many ways are there to process the first 10 characters into valid substrings, valid parentheses, such that whatever is the question, right? Now n is given, not only valid, like first 10 characters, and they might not be valid, right? Because n represents a prefix. The eventual character, the final string should be a valid, but the first 10 characters might not be valid, right? So how much it is not valid, that is given by the sum. What is the sum? So whenever in a parenthesis matching, generally we denote this one with the plus one, right? Opening bracket, and a closing bracket with a minus one. So a valid parenthesis sequence will be equals to 0, the total sum, and any prefix will always be greater than equal to 0. Any prefix of the string should always be greater than equal to 0. So the sum, this actually tells us that sum should always be greater than equal to 0. Thus it can be a state. So the sum tells what is the amount of imbalance that is still left. Like for example, let's consider a prefix like this. So here the sum will be plus 1 because one imbalance is there. One closing bracket is still needed, which is on the right hand side, will assume, right? So for the first 10 characters, the amount of imbalance that is there is given by sum. Okay, m sum. Third is k. K is how many characters are still left. How many characters, or instead of k we can also maintain some count or something like that. Right, we can maintain some count or something like that. So if k will represent how many characters are still left such that we can take consecutive similar characters. Now we want similar character, right? So we want a way that, let's say in the n plus 1th position we had placed a opening bracket. So here at nth position, we should have a way to know what was the character placed at n plus 1th position, whether it was a opening bracket or a closing bracket, and that is given by the last the last state, that is last, that will be 0 or 1. It will be 0 or 1. 0 represents a opening bracket, 1 represents a closing bracket, right? So let's actually understand the state again. Let's understand. Let's understand the state again, right? So if, what was the state again? If in sum, if in sum, and we have something k and last, right? So let's say we have uh, right, so we have first n characters. Let's say n plus 1th character is a closing bracket. The sum that is still left, let's say it is equals to we have to make a sum of 10 still. So if n 10 k, let's say 5 of them are 5 are still, or 2 are still left, right? And last is 1. So this represents that at this point, at this nth point, we have a sum of 10, we have an imbalance factor of 10, that is the total sum of this entire thing should be 10. Sum means plus 1 minus 1, plus 1 by this minus 1 by this, the total sum should be of this subarray should be 10. We want k should be 2, that is we can have 2 more closing bracket consecutively before this, as here we have taken 1, and 1 means the last character used, that is the n plus 1th character, is the closing bracket. So that is basically what the state represents, right? If n sum k last. Now let's talk about the transition n sum k last. Now here, if s of n is not equals to question mark, then only one way, whatever character is there, if it is the opening bracket, we'll have to take that case. If it is a closing bracket, we have to do accordingly, right? If it so let's say if it is the opening bracket, something like that, then we have to do accordingly. If s of n is equals to question mark, right, and let's say last is equals to 0, in that case f of n, it will become f of n minus 1. We can either take a opening bracket, sum plus 1 will be, sum will increase by 1 because we have taken an opening bracket here, or sum will represents the, it should be sum minus 1, I believe, because we are we have to still form a sum of sum, right? So it should be sum minus 1, sum minus 1, because why sum minus 1? Because sum is the amount of sum we need to form. If we are taking this opening bracket, we are adding plus 1 to our existing sum, right? So it is becoming, the needed sum is reducing by 1. So the needed sum is reducing by 1, k minus 1, because last was 0 and we have taken opening bracket, so same character, and last remains the same thing, plus we can take a closing bracket. So in that case, sum will become sum plus 1, k plus k minus 1. Now we are starting a new character, right? Before that, before the nth character, we are placing a closing bracket. Before that, it was opening bracket. So we are starting a new character, so it should be k, capital K minus 1, because we have taken one closing bracket, but we can take k minus 1 closing brackets more, and last should be last XOR 1, or it will become 1, whatever you want to write. So this is how the state transition looks like, right? This is not a backtracking, this is a DP question. So this is how the state transition looks like. So let's actually try to write the code for this. So int f, let's call it int f, yes, and also int mod let's take mod outside assembly, constant mod int and int f, and let's say here string s is there, string s int k is there and these things are there, right? Int k is there, int f, int n, int f, int n, um, rather int n, so idx, actually we are taking something, we are taking some, that's also right. So int n, int sum, int k, and int last, right? Int last. So if n equals to 0, what is the base condition? If n is equals to 0, right, we have 0 characters and we have a sum, right? If and then sum is equals to 0 and then k is greater than equal to 0, we can return 1. Else if n is equals to 0 or sum is sum is less than 0 or k is less than 0, in that case we have to return 0, right? Also we are doing a dp here, so it should be dp should be there. So int what should be the size? We can do a vector of vector of vector of vector. 4 states are there, so vector int 1 2 3 4 1 2 3 4 dp, right? So dp should be there. So or we can actually give it a size directly. So dp, in dp, first is n is 2 into 10 to the power 2, that is 200. So 201, let's take n, and then sum everything will be plus 1 or minus 1, so maximum 201. K is what? K will be 10, maximum 11, let's take it, and last will be 2. So that will be the dp array, right? So if dp of n sum k last is greater than equal to 0, return dp n sum k last. Else, okay, else is if s of n, if s of n minus 1, rather, if s of should it be s of n or s of n minus 1, 0 we are going up to, so it should be s of n equals to 0 means we are ending, we are starting at n. So s of n minus 1 is equals to is not equals to question mark. If s of n minus 1 is not equals to question mark, if s of n minus 1 equals to opening bracket, else if s of n minus 1 is equals to a closing bracket, right? So if it is a opening bracket, in that case, if last equals to 0, dp n sum k last should be equals to dp n should be equals to f n minus 1. We are left with n minus 1. Sum should be decreased by 1. We have taken some sum, so sum k should be decremented, because again, like, we are taking a same element, and last should be remaining the same, so last. Else dp n sum k last. Now else means the last element that was taken was a closing bracket and the current element is the opening bracket. So n minus 1 sum minus 1, k will become k minus 1, capital K minus 1, and last will become 0, right? So here if last is equals to 0, that means it is a last element was a opening bracket and current is a closing bracket, right? So dp n sum k last is equals to f n minus 1 sum plus 1, because we are taking a closing bracket. We need to make a sum of sum. We are taking a closing bracket which is the value of -1. So now we have to make a sum of sum plus 1, right? So sum plus 1, k minus 1, capital K minus 1, because the last element was the opening bracket and now we have a closing bracket, and last and 1, else dp in sum k last, dp in sum k last is equals to f. It was a closing bracket already, so n minus 1 sum plus 1 k minus 1, and last remains the same, last. Okay, so this is the part of question. If it is not a question mark, else if it is a question mark, now this is important. If this is a question mark, now if last is equals to 0, last is equals to 0, so we'll take the answer here, long answer. Let's take it outside only. 0L answer plus equals to long f of, we can either take, it is a question mark, right? So we can either take a opening bracket. If it is a opening bracket, where do we go? In n minus 1 sum minus 1 k minus 1, because the last element was indeed a opening bracket itself, so k minus 1, and last it remains the same. Answer plus equals to, or we can take a closing bracket as well. So long if n minus 1, we are left with n minus 1 characters, sum plus 1, because the last, so now we have taken a closing bracket, so the current sum has decreased by 1, so the required sum, this is the required sum, has increased by 1, k minus and it should be k minus 1 and last and 1. So else answer plus equals to, if it was a closing bracket, long if n minus 1 sum minus 1 k minus 1, as it was a closing bracket, current is a opening bracket, so k minus 1 and 0. Answer plus equals to, otherwise if it is a closing bracket, so long if n minus 1 sum plus 1 k minus 1, and last remains the same, so last, right? And finally here we come to answer mod equals to mod and dp in sum last in sum k last, in sum k last is equals to integer of answer, and return dp n sum k last. So this is else, and we should return this always, so return this, and that should be the else, if else. Okay, that should be it. So count strings, first is s is equals to s is equals to s, capital K equals to k, and return f of, so we are left with we have n characters initially, the total sum we have initially is 0. We can, whatever we take, we can make a change for k, right? We can make a change of k, and last can be 0 or 1, anything. So last character, let's say we have taken to be 0, and plus if we take to be 1, so if n0 k 1 and modulo mod. Okay. So here we'll take long, here we'll take long modulo mod, and finally whatever we get, we typecast it to an integer, so a integer in front of them, so integer. So this should be the final answer. Long sum 0L means 0 in long. Okay, so 2, Okay, 1, it should return 1 and it is returning 0. That's fine. K is 2, so it should have been 1. Output for this should have been 1. So n0, K is 0. N0, K 1. N0, K 1. If n sum K last, n equals to 0 and sum equals to 0, n equals to 0 and sum should also be equals to 0, only then it is a valid matching till now. And K is greater than equal to 0. K is greater than equal to 0, that's true. That should also be true, then return 1. Else if n equals to 0 or sum is less than 0 or K is 0, return 0. So K should be always greater than equal to 0, sum should be equal to 0, and n should be equal to 0. Fine, at that base case. So if dp n sum, okay, we haven't filled the dp values. So for int I equals to 0, I less than equal to n, that's why they are all 0 initially. For int sum equals to 0, sum less than equal to n, sum plus plus. For int k equals for int j equals to 0, j less than k, less than equal to k, j plus plus. For int last equals to 0, last less than 2, last plus plus. dp I sum j last should be equals to -1 initially. Everything should be -1 and then start computation. So let's run this. So this is giving 2. Is 2 the correct answer? It should be right. Uh, should be, I believe. Should be 1. We are getting 2. Why are we getting 2? Somewhere we are overcounting. Because of this, here it would anyways take both the cases and start with k. I don't think this is needed anyways, right? So we can just return if n0 k, if n0 k0, if n0 k0, that should be. Let's run 1. That's fine. Let's check a few more cases. So this should also give 1. So 3, this and 1. So this should give 1 as well. Oh, this is giving 0. How is this giving 1? Oh, this is giving 0. This should give 0. Uh, this should give 2. 6, 3, 6. This thing and 3 should give 2. So my output, it should give. It's giving 2. So let's try to submit this now. Hopefully this works. Otherwise we have to see. Oh, this works. Cool. So this is how we can solve the last problem. It was a good problem. Like, again, whenever you come to bracket matching, generally it's a good idea to take sum, because again, like, it's a property for a valid bracket sequence or parenthesis sequence is that the sum of all the prefixes should be greater than equal to 0. Like, you should always have, if it is less than 0, that means the number of closing bracket is more than opening bracket, which makes it an invalid parenthesis set. So that's why this is a good thing. And other than that, k, like as we needed k consecutive, not more than k consecutive, that had to be a state, and last would help us identify what was the last, because we wanted similar items, not more than k similar items together, right? So we need a delimiter to identify what was the last element. So that basically is given by this last. Okay, so yeah, that should be it. Other than that, although it looks a bit complicated, but again it isn't. Like if you don't have a question mark, then if you have a opening bracket, in that case if last is 0, that means the last element also is the opening bracket, then accordingly you will adjust k and last. And otherwise, if the current element or if the last element was the closing bracket, in that case you will adjust accordingly. So it's kind of very intuitive, not very difficult, right? So you just have to think a bit about how the state transition looks like. So, and that should be it. All right. Yeah, like I'll just recommend you just try this on yourself once. You know the states right now, so try to draw the transitions yourself once using this set of states, and see if you're able to come up with the same recurrence, right? So, yep. Thank you guys for watching. And how did this? Okay, I had that function. uh, yeah, thank you guys for watching, and I'll be seeing you next Sunday. And definitely try the last problem, because it's a very good problem. Multi-dimensional dp is really very important, and this is a good problem, easy and a good problem, right? So you know the states right now, so definitely give it a try. Cool. So